Okay. Yep. Okay, we are on day 2, lesson 9.2. Today we are multiplying polynomials. Hopefully you guys didn't have too much trouble on yesterday's homework assignment. I'll look at your grades when I put them in. If you did have any troubles, make sure we talk because this is going to be ongoing. Today we are discussing how we will multiply the polynomials. So I went ahead and I just did the warm-up because I want to get to it. Today's learning goal is I can or I will multiply polynomials. So 9.2, multiplying polynomials. It says the diagram shows that a rectangle with a width x, so you see that right here, this is the width x, and its length is 2x plus 3. Has an area of 2x squared plus 3x. And remember, we find area of a rectangle. Remember, area is, oops, I went to the side, I'll say, is our length times our width. So they're telling us when they did 2x plus 3 times x, they have the answer of 2x squared plus 3x. You can also find this product by using the distributive property. And this is something you will do today. The distributive property is, this is kind of like the box method that they're using. They took 2x plus 3 and they broke it up into x and x, because that would be 2 x's, and then 1, 1, and 1. And then all they did was find the area for each square. X times x is x squared, x times x is x squared, 1 times x, 1 times x, 1 times x. And then they added like terms. That is a possibility. If you struggle with any of this, we will learn that you can use the box method. There are different methods that we are going to be using. So, complete in your multiplying polynomial foldable. I believe that's the one I just gave you. So this sheet says multiply a monomial and a polynomial. So the example we are going to do here can also be put into your foldable. That way you can put it in your notebooks when you're reviewing for the test or for the EOC or EOQ, that you can go back to review this and it's there. When we multiply a monomial and a polynomial, first, my monomial. This makes us sound really smart. This is why I like it. It makes me sound smarter than I really am. Because it's pretty simple. It's just our regular distribution. My monomial is just one term, remember? So I have 2x cubed. And then my polynomial was my x cubed plus 3x squared minus 2x plus 5. The way we are going to solve this is, let's say I had this. If I had 2 times 3 plus x, we'd be able to find our answer. What would this answer be?
6 plus 2x.
6 plus 2x. We just distributed the 2, right? We did 2 times the 3, 2 times the x. The reason I show you that is, that's exactly what we are going to do here. I'm going to go ahead and I'm multiplying by the 2x cubed. So, we would do 2x cubed times x cubed. And what do you think you get when I am multiplying variables with exponents? What do we do? What do we do with our exponents? So, we add them. So 2x cubed times x cubed is going to give me 2x to the 6th power. My coefficient there's nothing to times. And my x, my variable, I had the variable 3 and 3, and so we add them. We go to the next one. Now I'm doing 2x cubed times 3x squared. You multiply your coefficients. 2 times 3 is 6. And my variable was to the third power to the second power, so it is now to the fifth power. I then do my 2x squared times negative 2x. 2 times 2 is going to be the negative 4. Because remember, we had negative 4 here. And x to the cubed times x is x to the fourth power. And then your last one, 2x to the third power times 5. You times your coefficients, so you would get 10x cubed. Once you finish that, what you should look at is, do I have any like terms? When I did this multiplication distributed, did anything come out where I have the same power that I need to combine? Well, no. We have 4 terms that we should have learned yesterday. Here's one term, 2, 3, 4 terms. It's the 6th, 5th, 4th, and 3rd degree. So that is our final answer. We have it written in standard form, or it's decreasing by its degree. So the difference between that and yesterday, remember, yesterday, when we add variables with exponents, they have to be the same. You change your coefficient. So something like 3x plus x is just 4x. Where today, if we had 3x times x, we get 3x squared. Yeah. Multiplying polynomials using a table. This is also on your folder. So this is the next one. This is what they call the box method. And it's pretty simple to set up. This method isn't bad if you have trouble keeping things straight. It does require a couple extra steps. But all I did to make it was I looked at my first term, x minus 4. And on that first equation, I have 2 terms, x and negative 4, right? So I'm going to make a box that's too high. And I'm going to put in x right here. And I'm going to say my negative 4 right there. I look at my next term, or my next equation, 3x plus 2. It's 2 terms. So I made 2 columns for it. 3x and 2. And then all you are doing is multiplying. We're going to find the area for each square. So on this first one, it'd been 3x times x. And 3x times x is 3x to the second power. Good. We go down to the bottom left. It'd be negative 4 times 3x. Negative 12x. You go to the top right, it's positive 2 times x. And then we have 2 times negative 4. And we have our answer. The last thing to finish is we now write it in standard form, and we have to combine any like terms. So I look at my variable and I find what the highest degree was 3x squared. So I start with that, 3x squared. And to be honest, how you show your work on this part's up to you. If you want to combine them now and just write it down, that's fine. So I see that I have a negative 12x and I have a 2x. If I find the value between the two, I would get
negative 10x.
So I could just write negative 10x and call that good. If you wanted to write negative 12x plus 2x, and then you'll simplify it later, that's totally fine too. That's showing what. And we have a minus 8. I double check myself, and that is your answer. So that is the box method. Yes?
Do both of the terms have to have two different numbers? Do the both of the parentheses have to have two different terms for this work, or can they have a different number of terms?
No, they can have different number of terms. So let's just pretend this was plus 4x squared. You would have just added on this box over here, and you would have that one there. So then I would have done x times 4x squared, and you would put the answer in that part of the box. That's a good question. I'm not going to go through and do the whole thing, but just to be showing. So if I had 3x squared plus 2x plus 4 times x cubed plus x. So they're different right now. There's 3 and there's 2. All this tells me is, on this first one, how many rows I'll have. So if I make my box, I know I'm going to have 3 rows. I'm going to have a 3x squared, a 2x, and a 4. With our second term, since there was 2 of them, I just have 2. X cubed and x. So that's how you set up the box method. Any questions about how we set it up? It's kind of funny. The box method is actually a method for regular multiplication we use in elementary. Alright. Next one. Multiplying polynomials horizontally. Now, to be honest, this is kind of confusing how they did this. They're trying to show you work, and I'll kind of point out the best. This is actually what I do. It might not be the most clear, but to me it always makes the most sense. To multiply horizontally, really what you're doing is pretty much like the FOIL method. So I have 2x squared plus 5x minus 1 times 4x minus 3. Okay, we're going to show how they did it here, but full disclosure, I would have done this easier by switching the terms around. And I would have said 4x minus 3 times 2x squared plus 5x minus 1. That way I'm only multiplying by 2 different terms. But the way they do this is we are going to horizontally, I'm going to start with black, take my first term, which is 2x squared, and I'm distributing it. So I remember we was talking about FOIL. So I'm going to go outside my first parentheses into this second term, because I have this group and I have this group. Yellow will get multiplied into blue. Every number in the yellow has to multiply to everything in blue. So 2x squared has to multiply to 4x. So that's what they're kind of showing here. I'm also going to do my 2x squared times negative 3. So that's what they're showing right here. They're showing FOIL. They did their first 2x squared times 4x minus 3. Then I'm going to do 5x times 4x minus 3. And then they're going to do the negative 1 times 4x minus 3. So every single term in your first group gets multiplied or distributed into the second group. They showed it this way. They said 2x, my first term, 2x squared times, and they just rewrote the whole thing right here. So they put the second term right here. And when I distribute that, 2x squared times 4x, well, you first multiply your coefficients. 2 times 4 is 8. X squared times x is x cubed. So 2x squared times 4x is 8x cubed. Then they did 2x squared times negative 3. Coefficients, negative 3 times 2 is negative 6. And you still just have x squared. So 2x squared times negative 3 is negative 6x squared. They went to their next set. So now I'm going to, I should have done this in blue. So that was my first term times my second group. If I go to this one, now we showed I did my 5x times the 4x minus 3. 5x times 4x is 20x squared. Multiply your coefficients. 5 times 4 is 20. X times x is x squared. 5x times negative 3. 5 times negative 3 is negative 15. And we had the x, so negative 15x. And then our third one, I'm going to multiply by negative 1. Negative 1 times 4x is negative 4x. And negative 1 times negative 3 is 3. That is our answer so far. 8x cubed minus 6x squared plus 20x squared minus 15x minus 4x plus 3. The only thing we have to do is now we have to clean it up and do like terms. So I look at my variable. They're all x. So you look for your largest value or your largest degree, which was to the third power. There was no other x to the third power, so it's alone. So I have 8x to the third power. When I look at x squared, we see that we had two of them. We had negative 6x squared plus 20x squared. So negative 6 plus 20 is negative 14x squared. Did I say negative?
Yeah.
Positive. Negative 6 plus 20 is a positive 14x squared. We then also see I have negative 15x minus 4x. Same terms. They have just x to the first power. So negative 15 minus 4 gives us negative 19x. And we're left with just 3. So your final answer, 8x cubed plus 14x squared minus 19x plus 3. If I'm being 100% honest with you, I don't rewrite it this way. And I get what they're doing. I want to make sure you understand it. They just showed that in this first group, I have 3 terms. So I had term 1, term 2, term 3, and they just showed distributing to the second term. That's perfectly fine if you want to rewrite that way. Honestly, when I did this, I always just wrote it as I went. I draw my arrows. 2x squared times 4x, or times 4x, and I wrote down 8x cubed. Then I did this times here. 2x squared times negative 3 is minus 6x squared. And then I went to the middle number, and I got 20x squared. And then I got negative 15x. Whatever you're comfortable with, the only difference is this one, just laid it out. And just make sure you didn't make that mistake. This is FOIL. So the next one they're going to talk about is with multiplying binomials using FOIL pattern. FOIL just stands for first, outer, inner, last. So when they say first, this is all color-coded, so it should make sense. I'm going to zoom in for you. I had terms, 2x plus 3 times 4x plus 1. So first terms means the first terms from each. 2x times 4x gives me 8x squared. Green is my outer term, so the ones on the outside. Well, this is on the outside, and this is on the outside. Because if you look at it as a whole, everything there, 2x is on the far left, positive 1's on the far right. So 2x times 1 is 2x. Then you look and you do the inside. 3 times 4x. Those are in the middle. That's 12x. And then you do the last terms. Let's see, you did them in blue. 3 is the last term. 1 is the last term. So that gives you 3. The only thing they have to do here is we have like terms. So I should finish this as 8x squared plus 14x plus 3. FOIL is just another way to remember to multiply all the terms. I do the first terms, do the outside terms, I do the inner terms, and I do the last terms. So right now, to be honest, between this FOIL and this method, it's really whatever you're most comfortable with. In real life, some people use the box method. Me personally, I use this. I have some friends that when we talk about multiplication, they use FOIL. They still write out FOIL every time. They go start, they go. And then when they do the first terms, they cross it off. Then they do their outside terms, they cross it off. Inside and last. It's just whatever you have to use to check yourself to make sure that every term in the first equation gets multiplied to every term in the last one. So, I'm going to pause there real quick. We have 4 of these monomial multiplications. I want you to go ahead, get the answers, and then we'll come and check to see did you get them right. So, we have 1, 2, 3, and 4. Work on them right now. Check them with a partner. Ask questions if you have them. I'll work right now and do the answers, and we'll talk about it in a second. Alright, so real quick, I'm just actually recording so it's on the video for you if you need to watch this again. Okay, so there's our answers. Okay, we have 2 minutes left, or 1 minute left, so I'm going to give you your homework. If I definitely did not make a mistake on number 3.
Yeah, you did.
So,
And Tessa and Reagan didn't totally help.
No, 3's are really good. Tessa and Reagan did not help.
okay, your homework is worksheet 9.2. Multiply the following binomials. Write your answers in standard form. Holy cow, this is a lot more than I thought. And then
No!
Even 28. Even.
They're all even numbers.
I don't even understand how to do it easy.
No!